Oops, I was not on the stage. Okay. Hello, everybody. Good morning or good day, wherever you are. I am streaming today's Rust Gamedev Meetup from the same conference that I was at last year that I streamed Rust Gamedev Meetup from. I forgot about it, but it's like they run their meetup or their conference on the second Saturday of each, I guess, January, and so that's the exact same time. So this will always be the January experience. But I wanted to show something kind of cool. I don't know how like good it will come through on camera. Okay. So in the hotel room that I'm in, you probably can't see it super well, but we got like this pool right here of a whole bunch of ducks. And it's kind of interesting how this hotel does it because for the whole winter they'll keep that water warm, so that the ducks can stay there. And so yeah, it's really not coming through as well as I can see it here. But there's like a migration of ducks going for food right now. Okay, maybe you can see it. But anyways, we are not here just for ducks or seeing the Canadian winter, but also for the Rust Gamedev meetup. So we have three different talks today, and I'm pretty excited for all of them. We have some speakers that we haven't heard from in quite a long time, as well as someone presenting something new. So without further ado, I'm going to transition us over to, and this is like the other thing about using my laptop is I have to like do the entire show running from a small screen here. Okay, cool. So we'll be back in just a second with Eknan. Okay, so hello, Acton. We have not heard from you in quite a while. I think the last
Yeah,
time we were like hearing about Bonsai DB and stuff like that, and so it's been a while. You've been working on some new projects. Let us know what you've been doing.
kind of new and old. Technically, I think in the last demo, I was showing off a little bit of GUI as well as Bonsai DB.
Oh
I
yeah.
renamed GUI though because there was another framework in Python that I didn't think there would be much confusion over, but the first place that I posted the first alpha of GUI, the first comments were just bad name. And I'm just like, okay. So anyways, I'm now introducing Cushy today, which is a reactive GUI framework for Rust. I've built it to be very WGPU centric. So it's rendering not using any existing widget toolchains. And then I've been inspired by Leptos. Leptos is a kind of reactive data model that's using signals and stuff. And overall, I found it to be really fun. So here's just diving straight into a couple of examples here. This is a button that increments itself. So dynamic is something that stores. I'm sorry, I'm having. Is there some background noise coming through? There's just all of a sudden leaf blowers outside, and I'm really worried about the noise.
Oh, sorry. I know you're all good. I think we're
Okay.
we just hear you. Yeah, you're good.
Sorry, that is incredibly distracting. But anyways, the dynamic is the reactive component. It's kind of like a fancy arc mutex that you can attach behaviors to. So in this particular example, the behavior that we're interested in here is count.set count.get +1. So every time that this button that we're creating gets clicked, it's going to be executing this closure, which is going to set the counter to whatever it is +1. And we're using the counter as a label in the button. And we can see over here that we have a live little demo, which might make you wonder what in the world are you even looking at? And yesterday morning, when I was realizing that I needed to somehow present about Cushy, I was like, you know, it'd be really fun is, less than 24 hours before the presentation, writing some presentation software. So what you're seeing on the screen right now is the actual kind of inception version of this slide. This is actually including the code for the main file that you're seeing directly, and it's using the syntax library to do syntax highlighting and all that fun stuff. So I've tried to make it very easy to use. But just the fact that I even reached for Cushy to make my own presentation software less than 24 hours before a presentation should hopefully give you the idea that I really enjoy working in Cushy. So let me show off some more examples here. This is kind of taking it a step further with the dynamic system, and it's showing off how animations work in Cushy. So every time we click this button, we're going to generate a new random color, and we're going to transition the space that we have here, which has the color, to a new color over 1 second with an easing function. And this is all just being driven by the dynamic system. There's traits called linear interpolation and percent between that power a bunch of things. And I've implemented them from a lot of traits, and a community member has even made it so you can derive linear interpolation on custom types, which is really fun. So all that's to say that the system just kind of magically works, which is really cool. You kind of tie stuff together like this color.map each. I'm just using the format macro to format the hex string down here, and then I can just take that dynamic string that I have here and literally just throw it in the interface, and it just magically shows up as a label. So I've tried to make Cushy really straightforward and easy to work with. The only other fun thing about this that I wanted to call out is that the state for the animation is actually tracked by the closure itself. So this variable animation here is holding on to the most recent animation handle, which can be used to cancel animations. But what it also means is that if I click this button a bunch, I don't have like a bunch of different animations kind of competing. This is overriding the last animation, canceling it, and storing the most recent animation to keep it going. So anyways, there's a lot of really cool stuff working here. So then, let's take this even a step further. And now I have two picker widgets that are picking a color, and they're going to fight against each other in a lot of systems, right? Because when I change the HSLA, it's going to update the RGB, and the RGB is in turn going to be trying to update the color as well, which in theory should update the HSLA. But the way that everything works in Cushy just kind of makes this magically work, is that if I go in here and pick this, and I drag this lightness slider up, we can see that the RGB sliders are all going to full white. Now at this point, if the bidirectional bindings weren't working the way that I would personally expect them to, and that I think that most people would intuit them, we would have lost the hue color. But as I drag this back, you can see that the hue is actually kept. And that's because the HSLA picker is kind of the source of the change. And so by the time that the cycle that would normally happen where it updates the color, then goes to RGBA, then goes back to the color, and then comes back to HSLA, at that point, because it's the source of the change, it can't actually update it again. So it kind of just breaks the chain at that point. And that makes it so that it kind of just magically works. And I'm sure there's some fun edge cases where that doesn't work. But so far, as I've been using Cushy and building things with it, it just works, and it's great, and I really like it, and it's fun. So kind of what's next? I initially released the initial alpha on December 18th, and then shortly after that I added multi-window support. And then I've been working on generalized WGP support as well as off-screen rendering. That's technically all done. What I'm really working on right now is just kind of polishing up docs. And I started working on a user guide, and I've been trying to flush out kind of an initial version of that. It's not going to be anywhere near complete because Cushy itself is alpha, and so there's a lot of work to do on the framework. But just before people can really understand how to use Cushy effectively, I feel like the guide is a good place to kind of describe a lot of like why Cushy works the way it is, whereas the documentation is a better place for the source of kind of how it works, I guess, in my view. So yes, that's kind of what's going on with Cushy, and I tried to keep the demo pretty straightforward. If there's any questions, I'm happy to answer them. I'm not sure how Q&A works nowadays because it's been a long time.
Hey, all good. I have a ton of questions, and I'll keep an eye on chat and also on the Rust Gamedev Discord. So if you have any questions, feel free to toss them in there. But in the meantime, I'm going to ask them mine because
Sure.
I remember Acton, right before we started today's meetup, I'm like, oh, are you going to just have the presentation and show anything off? And you're like, the presentation is the demo, and I'm like, oh my gosh, that's so cool. So I'm so happy that we got to see that and kind of so like see it interacted with and stuff. And so the first question I have is kind of how does this fit in the ecosystem of existing Rust GUI frameworks? And so the ones mainly that I've used, I know we use like Iced for Valoran. I think we used to use Conrod as well. And then for my own personal products, I've been using eGUI. And I quite like that if I'm doing like web application kind of things. I'm maybe using it in a different way than other people would, but I enjoy it quite a lot. And so how do you find that yours or that Cushy fits in?
So I think that the closest framework that I would say that I'm trying to compete against. I'm not really trying. I think that the more frameworks, the better in the ecosystem. But if you want to call it competition, let's call it competition. But I think Iced is kind of the open source equivalent that I wish that I was happy using, but every time I use it, I find friction points that bother me personally. And that's not to say that it's a bad framework. It's a great framework. There's a lot of people using it very successfully. But basically, there's just some friction points that I thought that I could solve slightly better. It is not currently run at all on WASM. I do eventually want to do that, but I'm not like My goal is to make a game someday, as odd as that is. That's how I started 3.5 years ago when I first showed off Cosmic Verge. I think February of 2021, I think, is the first time I
Yeah.
showed up here. And I still want to do that someday. And I feel like Cushy is now at the point that I can start building a very basic, I want to say UI centric game. But I don't really have plans on putting that in a web browser these days. I've kind of de-emphasized that. I'm a team of one mostly. There have been a couple of people who have contributed, but 99% of what you've seen today is all just me. And so while that's true, I'm going to just continue pursuing what I'm interested in. And WASM has a lot of sharp edges that I don't want to touch right now with WGPU and send bounds and stuff like that. And they're all tackleable. I just don't want to deal with them today. So from that standpoint, Cushy is really meant to be a desktop centric framework to start with, and eventually, hopefully, it'll kind of spawn out to other related facets.
Awesome. And then I have one question here in chat. I think it's sort of similar. So there's like, I suppose Floam is the UI library for Laps, and kind of like looking at how that compares. And I'm just checking it out on my screen, and it looks like it's like a code editor type of thing. Maybe one question I had that's sort of aligned with this, or you can add on to this a little bit, but when it comes to UI frameworks, I think one of the biggest things that a lot of you'll have a very strong opinion on is how you do layouts on the screen, and how you move things around, or how you allow the developer to decide how they want their screen to look. And so what kind of opinions do you have on that with Cushy?
So it's inspired a little bit by Flutter, even though I've never used Flutter. It's just that when I started envisioning how I wanted things to work, I started to want to design something that's very composition heavy. And so, like if you have three widgets, like three labels, and you want to lay them out on the screen, you have to decide what strategy you want to use. Do you want them to be stacked vertically on top of each other? Do you want them to be stacked horizontally? Do you want them to wrap kind of like text, go left to right and then flow onto next lines? And those are individual widgets in Cushy, and they take a widget list and present them. So there is a common way to create one or more widgets. That's a widget list. And there are multiple layout widgets that accept a widget list to be able to present that to the user. And so ultimately, like if you want a new layout strategy, you basically just implement a new widget that accepts a list of widgets and lays it out how you want to configure it. So you kind of have infinite flexibility from that standpoint, because you can design whatever you want inside of that paradigm. But it also means that from out of the box, I'm essentially building a bunch of little composable widgets that work well together.
Okay, super cool, super cool. And then I suppose when it comes to actually taking Cushy and using it in different cases, so right now we were sort of seeing an application that presumably is just using Cushy for like the entire UI. But have you thought of any work of integrating Cushy as a, I suppose, plugin for Bevy, or so that it could work with other engines or other, or maybe if I wanted to just say I'm going to use Cushy, but I'm also going to have my own renderer underneath. I'm going to use WGPU or anything like this for other things. What does that look like?
So I don't think that I'm a WGPU expert, sorry. But they have a development article called "Encapsulating Graphics Work," I think is what it's called, and they kind of describe a prepare render type API that they recommend for creating kind of reusable middleware, I guess if you want to call it that, or rendering passes. And so that's what the next version of Cushy exposes, is a way for you to essentially create a render pass and render it directly inside of your own WGPU applications. I have no idea how that actually works to integrate with Bevy, but one of my community members is interested in pursuing it. I just haven't released this version yet, so it's only on main. So once it's out there, I hope that other people can utilize it in any WGPU application.
Nice. And I guess on that topic, have you found, so with having a community that might be interested in Cushy, or just in the work that you've been doing, have you seen any cool things that other people have worked on within the Cushy space so far?
Not yet. One of the first community members kind of started trying to make an application launcher before I barely had any widgets. And that person continues to revisit it occasionally here and there, and it slowly gets better and better. But I think that mostly what I've been building is the most complex things with Cushy so far. So I would love for more people to try to break it.
Yeah, awesome. And I think definitely I want to take a look at the source code for the slides, because one project that I've been super interested in is when I give talks. I think the talks that I give tend to be lectures. They're not interactive enough. I want to do some things that people can play with, and having a framework like this that allows me to is like fully reactive. There's like already a demo of how to do it with slides. What I want to try hooking up is like the ability to do like maybe either quizzes or votes or anything like this, where it can connect to like a server. People can interact with it on their devices. And currently, like the ways that I've tried it with eGUI a little bit. I've tried it with Bevy, kind of just playing around with like, okay, well, does this idea work? But I mean, this is an amazing proof of concept that yeah, like you can have some slides going, you can have some interactive elements, and so I think definitely I want to try and play around with it, mess around with it, and see how I guess maybe like the biggest thing for most people when they touch a UI framework is like, does it fit their ergonomic needs? And so I'm definitely interested to play around and kind of see what I find about it. So for like the source code of the presentation, that is that on GitHub already?
It is. If I can get my window manager to break out of it, I can probably. I was looking at Graphite, who's hopefully going to be demoing shortly here.
Yes.
But yeah, it's a Cushy Show on Consu Labs on GitHub, and the actual presentation that you were looking at is this introducing in Cushy presentation, and so that's
Okay.
the entire presentation. This probably should be built in. I just needed a place to pull in range of a code file, so that does the whole white space stripping and stuff like that. But yeah,
nice. And so wait, the whole presentation's like just under 200 lines. It looks like.
Yes, although remember, I'm kind of creating like a library to go along with it. So this is the actual like framework for how the kind of the rusty DSL of the slides, like the show framework or whatever, is actually powered. So so
And actually,
this
can you zoom into this a little bit? I'm kind of curious on how this Rust DSL that you have sort of like created right now is set up.
Actually, it might be easier for me to poke around inside Visual Studio Code rather instead. That way I can actually like F12 to jump to definition. So, so yeah, like this content slide is a helper that I have inside of the actual presentation, which is essentially creating kind of the top and the bottom places and kind of creating the area in the middle. And so that's done by creating a V-split that fits the top part and the bottom part, but by default it expands the middle contents in the split. So then, you know, I put the title up top, and then I have special little helper slide elements that are the slide index and the slide count. And so this is kind of a good place, I think, to show how these slide elements actually work. I have a trait called slide element that has a make widget, and there's kind of a context that gives you some access to information about the slides, the deck itself. So like that's where the slide index actually comes from. So I'm just literally creating a label behind the scenes for whenever the slide index is used inside of slide content. So ultimately everything implements slide element, which just has a responsibility to create a widget. That's how it all ties together.
Okay. And then I think you also said an interesting thing that you described as like the Rust DSL. And so if you hop back over to your main code here, I think the one thing I find interesting about this is like, as you're creating the slide and everything like this, stuff like content slide, H-split, expand weighted, I would expect these normally to be, so I assume they're imported functions or something like that, but it's very clean and concise. It's not what I normally would expect from, I'd expect that to be a macro rather than just actual Rust like functions being called.
I try to avoid macros by default because they mess with the editing experience so much. And honestly, that's one of my friction points with a lot of UI frameworks out there, is that they're very macro heavy. Macros have a place, and I think that they're wonderful tools, but I try to get as far as I can with just the base language, but as my initial approach.
Yeah. Okay. That's super cool. Yeah. And I mean, the way that it's laid out right now, it definitely looks a lot more akin to not exactly HTML, but you're describing the way that you're laying it out a lot closer to HTML than it would feel like you're doing in a lower level language. And so, yeah, this is very interesting. Yeah, I definitely really want to check this out. I think it would be a pretty fun thing to play with. What kind of ideas do you have for the upcoming future on Cushy?
So I mean, ultimately, the biggest thing is more widgets, because the most people are going to run into limiting factors of what widgets are available. I don't have like drop down buttons yet, pop up menus, or menus at all yet. I do have like popovers, overlay type things, but I don't have them all tied together to make a drop down widget, right? I have a table view, or so I have a grid view, but I don't have an actual table view. I have scrolling, so I have like all these individual parts, but I'm kind of missing the more complex widget still. Don't have multi-line text editing. So there's still a lot that definitely marks Cushy as alpha. I'd say that most of it's missing functionality, less than missing building blocks at the moment. So I'm kind of continuing to refine the building blocks that I've made, but I feel pretty good with kind of the foundation that I built.
Yeah, it definitely is a pretty nice foundation. So I'm super excited to see where Cushy goes in the future months. So Acton, thank you very much for showing off today.
Absolutely, thank you.
Perfect. We will be back in just a minute. Okay. All right. So
Hey,
we are back with Zach, who's going to show us. So I actually just realized this. I thought it was Astronomic at first, but it looks like it's pronounced Astrotronic, I think.
no, it's Astrotomic.
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 Okay.
Yeah.
Perfect. So, Zach, I'll let you take us away. Show us what you've been working on here.
So this is my game, and this is actually the world we see on the trailer. So yeah, we have a Word file where you can, I can actually close this game and it will open exactly where we are. And the word has a lot of atoms that are these individual particles that you see, and you can actually explore it. The world is actually not made yet for like bigger worlds like in Minecraft area, because if you explore it too much, you actually the word file will get too big. But we are working in like compressing it so that you can actually play it normally when we add like procedure generation to the word and stuff like that. So you see, if I just go left, the word actually just keep generating. But if I go back here to where we were, the word is still here. So yeah, we have a chunk loading and deloading system. And besides that, you can see we have a lot of water here. We have some sand, some grass, some dirt, and this down here is actually, I mean, we also have this tool that you can destroy and shoot atoms like this. And here is actually gravel that you have down here. And when you get like more down, you can, this is just stone and it is that infinitely. So yeah, this is the word. And yeah, we actually also have lava, but we didn't made yet the interaction. So yeah, it's still like this. But yeah, that's it. And we are going to add a lot of stuff, but the game is still pretty early. I would say it has like 4 months of serious development. And yeah, we actually just released the new version that you can find on GitHub. I can probably link it somewhere.
Awesome. Yeah. So, I mean, when I saw this, I think the first question that comes to a lot of our minds is like, what are the algorithms you're using behind this? And so, are you using some type of engine in Rust? Are you doing this all from scratch? And then, what does it look like to actually simulate a lot of this?
So yeah, this we actually are using Bev, and we have like a algorithm to handle all these atoms. What we actually do is we like slice the word in 4 parts, and we do the simulation actually 4 parts. And so each of those 4 parts, we can send all of the chunks to different threads, and then we can multi-thread the simulation so that it can run at runtime, and we can handle all those atoms. And I can actually show something. I can show the debug mode. I will close the app and open the debug mode.
For sure. I'm just pulling up the repo here. I'll put it in chat, but then I'll also make sure that people can find it here afterwards.
Okay. So yeah, I just shared it.
Oh,
I
yeah,
think you
there we
have.
go. Perfect. Oh my
So
gosh,
this
this
is
so cool.
So this is actually in debug. So when I like put some atoms, you can see these blue rectangles is actually the stuff that we are updating. The rest don't update, and we can actually see, like, if I do a lot of atoms, you can actually see is we are separating them in chunks. So what we do is we do like a checkerboard pattern that we get slice up the word in 4 parts of chunks, like the odd ones and evens in 2 dimensions, and then we can throw all of those chunks in different threads, and they can simulate themselves.
Oh, and just to clarify that, so what you're saying is each one of these chunks is independent. Now, what I'm kind of curious about is with that is what happens when chunks are right beside each other, and maybe something will something from one chunk ever affect something from another chunk?
Oh yeah, so what we do is, because of the slicing, what we do is we get one chunk, and then we don't get the one that's right beside it, And then what we do is we slice up some of the neighboring chunks data, and we borrow it, and then we can have like a one chunk updates itself. It gets some borrowed data from the neighboring chunks, and then we update that,
Oh my gosh, that's super cool.
Yeah,
Okay, yeah, I think I see what you're saying. You have like an extra border around the area that you're dealing with,
yeah.
so that you
So I
can.
can actually draw something here if I
Wait,
can.
are you drawing inside of the game? Okay,
Yeah.
nice.
So like if this is a chunk, we get like half of this chunk data. That would be this, and then this chunk updates itself, and it gets this borrowed data, and this, if I can get here, this other chunk it gets this data, so we actually don't use unsafe Rust. It's all safely done.
So
And
in my mind, this is very similar to like the game of life, where you're doing a simulation on this entire world at once, and then you can say, okay, so we have this frame of the world, and it's all going to be borrowed, and so like nobody can mutate it or anything, and then we're gonna make a new version of the world that's completely mutated, but we can do work on it separately to update that. So is that sort of how it works?
yeah, because we have like update steps, and we run each update step, and we run this step 4 times for each slice of the chunks we get.
Okay. Yeah. I really like how you could just like sort of hop into whiteboard mode with this.
Yeah.
That's such a useful thing to have. And also, yeah, like Kate, I like even more the fact that okay, you're working on this whiteboard, and then you have to move to the left a little bit to get more whiteboard space.
Yeah.
So I guess maybe one thing I'm curious about on the game design side is now that you have some of these core mechanics of how the world is being built, like there's a lot of optimization on that side, but also when it comes to the design, what type of game are you looking to make with this?
So we actually are trying to make something similar to Starbound. I don't know if you heard of it. We want to have like different worlds, and that you can have a galaxy that you can travel between worlds, and each world will be like a world, each planet, right? Each planet will be like a world that you can go in. And we actually are like still deciding on the history of the game. but we have some stuff already done.
Mm-hmm. Okay. And I guess in that way, do you imagine when it comes to the simulation or sort of what you've seen with the optimization, there's probably an upper bound on how much you can have either rendering at once or how much you can have stored to the disk. And so are you using those sort of as constraints? And so maybe um, for example, you can only have a planet of a certain size so that while they're on the planet, you're going to keep everything stored in chunks. But then after they leave the planet, that will get reset or deleted or anything like that, so that they can get into a new planet and start exploring again.
So like what we were discussing that, and probably the major bound is data that we store of the world, because like this world we didn't compress it, and it's like I think 50 megabytes, and by just walking a little bit we get that much data. So that's probably the upper bound. About this absolute size of the world, I think it will not be a big problem because of the how chunks works, and we can just store it to the hard drive.
Okay, I see. I see. And then also just on the optimization side, because I'm very curious about this. When it comes to doing the simulation, is it perfectly parallelizable where the entire simulation that you're doing can all be done? Like if you have more CPUs, it's going to go faster, or are there some things that you have to do in lockstep each frame?
Yeah, so like I said too, we have 4 update steps for each no, we actually have 4 slices of the chunks. So we actually cannot, like, for each chunk we spawn a thread and update all of them at once. We can't do that. We have to do that step that I did, that we separate them in 4 single steps, and then we simulate this. So
Yeah.
a better CPU will probably help a lot with the game, but there is not 100% the way that you said it.
Okay. Yeah, sounds good. And then also, I suppose when it comes to Bevy for this use case, where in my mind, Bevy, it has like a really great system for being able to create lots of objects and spawn them around, and you have them in your ECS, and you can change their archetype of how they're set up. How does the problem of this project or this game map to using Bevy? Like, does it work pretty well within what Bevy is meant to do?
So yeah, Bev helps, but like all of the chunk and all of the logic beside this behind the simulation, we actually don't use Bev at all. We actually only have one Bev resource that is called Chunk Manager, that like it deals with all the chunks, because I tried using like one entity for each chunk, but it didn't work of how the queries worked with Bev. I probably would have to do like unsafe Rust, and I gave up, and I like made the chunk manager to do that. And we probably maybe will ditch Bev in the future, because I think you'll talk to I think you remember Ziklek from the other meetup. He's doing bones, and we probably are gonna migrate to bones in the future, because we can do our stuff of the game, and Bev is not like a requirement for what we are doing.
Yeah, I think that's a good point. Where, like for example, with Valorant, we have this question come up quite a lot. Like, why didn't we use Bevy to create Valorant? And I mean, for us, it's because Valorant started before Bevy started. But in the long run, it's also because um, stuff like Bevy or Amethyst or any other Rust game dev engines, the main idea for them is that they give you a lot of functionality to do whatever types of things you need. They're very general and they're very good for games where you can work within those confines. But as you start needing more, or you need to be more custom, then a lot of the time you're like, okay, well, it's awesome that they're giving me input handling and they're giving me ways to handle my data and do all of this, but I can rewrite that myself, and that's not where like the main components of the game are. And so yeah, I think this is a super cool case where you have that idea of maybe it is possible to split it out. And in that case, is most of your logic separate from Bevy, so it should just be like rewrite the input layer? Is that sort of how it would work?
Yeah, I would say not 100%, because like that. Let me show something in the game. When I pull these atoms, each atom I pull, we actually spawn a bev entity. So at least for that, we'd have to use a different type of stuff when we ditch bev. But we probably wouldn't have a hard time migrating to another engine because all of the chunk stuff is just separate from it.
Yeah. Okay. So yeah, this is super cool. So I'm super excited to hear where this comes in the next few months and what you get up to working on. So you mentioned that the entire product is open source and people can go check it out, right?
Yeah, it is on GitHub.
Perfect. Yeah. So I'll make sure to. Oh, I haven't finished the blog from last month's meetup, but I'll try to put it together for anybody who wants to check out more of the details. And I also see that this is under Spicy Lobster Games, and so that's the same thing
Yeah,
that we saw last month, right? It's more of like a collective for several games.
yeah. We Spice Lobster actually has their main franchise of games that is called Fish Folk, where they do their fish-based games. But we also have Astronic, that is this very different game, but it's still really cool.
Yeah. So what are you saying that Astrotomic is eventually going to get a fish theme in some way? Is that what you're saying?
Oh, for sure, we're gonna have some fish stuff there.
Nice. Awesome. Well, Zach, thank you very much for showing off. I hope we can hear from you in future months. And also, I'm just going to check quickly. I was not in the Rust Gamedev server. I'm just going to check if there's any questions there. All right, well, looks like you're good. So yeah, Zach, thank you very much.
Oh, for sure. Thanks.
We'll be back in just a moment with Kevin. All right, so we are back with Kevin, who's going to be showing us some updates on Graphite. So it's been a few months, Kevin. I'm super excited to hear what y'all have been working on. And now I will say, I did read your 2023 blog post, and there's a ton of cool stuff in there. So I'll let you take it away.
Yeah, we basically have not just a few months to catch up on, but almost an entire year, because in these past few months, and especially in the last month, we have basically reached the minimum viable product for what we have spent the past year building, and that is being the world's first procedural vector graphics editor, which I'm very excited to show you. So, Graphite, if you are just tuning in for the first time, since it has been a few months since we've actually presented last time, we are really trying to build kind of a brand new attempt at making a fully encompassing 2D graphics editor for everything from painting, digital painting, to photo editing, to graphic design, vector illustration, designing SVG files, and then pretty soon we'll also be moving towards animation and motion graphics. And then eventually in the longer term, we'll also do digital publishing and pretty much anything else that you could imagine that is 2D based. So 2D artwork or 2D design, that is pretty much all within scope, because there's really no reason to have those be separate programs if you can have the crazy ambition of getting it all done eventually in the same program. Anyways, so I would like to now show you what it looks like to do procedural vector graphics editing. So one example here, and we have a tutorial on the website. I would suggest if you visit the website, you can just open this tutorial. It's a 17-minute video that you can follow along on your own computer and give it a try yourself. But what we can do here is we can click on the layer for our sun rays, and basically go and change this to be defined. Instead of having 8, we could have, let's say, 5. And then for the other one, of course, we could make that match. And now we have 5 instead of 8. So it's very easy to procedurally define these kinds of things. And what this is actually using here is it's using a circular repeat node. So I can now simply open the node graph by clicking on this button. And what you have here is you have the data on the left side that is feeding into these layers on the right. So we saw our layers in the layer panel, but under the hood, when you actually go and click on that node graph button, you're able to see that these are the nodes that actually build up to the content in the layers. So for example, we have our rays here, the sunlight rays, And we have a line, and that's being fed in. So we can, of course, change the parameters of the line with the X and Y values of the started endpoints. And those feed into the circular repeat node. So as we saw just a minute ago, we changed that from 8 to 5. We could, of course, change it back to, I don't know, 12, and then change it for the other one as well. And now we have 12 sunlight rays. And we can then change the offset and kind of make it spin, as you can see in the background. Spinning like that, based upon just changing the angle offset. Also, the ability, by the way, to drag left and right on these number inputs is a new feature that I'm very happy we have, because it was quite a quality of life improvement when we added that a few months ago. Then it feeds through the stroke node. So this applies basically the stroke color. And of course, we have options like controlling whether it is a rounded or a square or a butt cap. And then, of course, the color, the weight, and everything. So yes, this is basically a very easy example of procedural editing, where we have a node system that feeds into layers. And this is also something that's relatively unique to Graphite, is that we have this concept of these layers, and they stack vertically on top of each other. You can connect them vertically like this, and that's how you can do your normal compositing, bottom to top. You stack things on top of each other, and it makes it very easy because you're actually using the layer panel most of the time. You don't have to actually bother touching the node graph at all until you decide to do something a little bit more sophisticated. So to show you a little more sophisticated of an option, we have another demo artwork that we just released for this holiday season. And this is an example of a Christmas tree, which is decorated procedurally based upon the placement of these lights. So I can show you how this works in a second, once I move the lights around a little bit. So we're actually initially defining just a polyline, and that's what you see in blue. That is just several different points that get interpolated then by a spline from points node. So this is using a cubic spline to turn what initially starts out as just these lines. It's currently previewing just the lines, but they have no stroke, so therefore you can't see them. But going back to the full view, you can now plug them into the spline from points. So if I, for example, just hid this, if I hid that node, now, of course, we have just the original lines as opposed to those being interpolated by the splines. But I'll unhide that node. And now this node actually feeds through, and we give it a stroke here, and that's this color here. And we give it a transform, and then that becomes this wire. So if I go ahead and hide everything else besides this, we have just the wire, which is, oops, there we are, yes. So we have our wire, and now the next thing, I'm just going to add up another layer at a time so we can show how this works. So I'll add the blue lights. So the blue lights here, which come from here, they are basically taking those same spline positions, and what they're doing is they're sampling points along that spline. So if I go ahead and temporarily just show what that looks like, you can see we have, oh, actually we're not displaying it with any stroke, but if I quickly add a stroke, or actually if I plug it in to replace the other stroke, you can now see we are sampling points here, 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 here. Those are the positions. Every angle there is a position where we actually place the different Christmas tree lights. So now you can see those lights are showing up at those positions. But I will set it back so we are displaying the wire itself. So that is taking this output and putting it in here. So yeah, now we have our wire, and we have the bulb. So the bulb is defined like this. We have the shape. We originally created one shape, but now we share it between 3 copies because we have the 3 different colors, but we do feed it a different fill. So this one is the blue fill, this one is the red fill, and this one is the green fill. So we get to reuse it. And then also this base, which is, this base here is this thing, that shape there. That gets reused 3 times. But then of course we have the different color. And we have a different sample position. So this sample points has a spacing of 300. They all have a spacing of 300, but they all have a different offset. So one has an offset of 0, the other has an offset of 100, as you can see here. and then the third one has the offset of 200, and that gives us a different position for each of the lights. So now if I go ahead and re-enable the lights, you can see that the lights all show up being spaced 100 apart, and there's 3 different colors, which means that we end up with 300 apart amongst the group of 3. Now we can, of course, add back our Christmas tree and our star, and we can then simply drag this around. And there's basically, as far as I'm aware, besides something like Houdini or Blender, which is mostly a 3D tool, there's really no other tool in existence that allows you to procedurally do something like this, where you make vector graphics with, for example, just the pen tool, and then procedurally decorate the tree. So you'd normally have to, in another editor, you'd have to go and manually place every single light and hope to eyeball the positioning so it's as close as possible to being evenly spaced. And then every time you decide you want to move the light strand a little bit, or the wire strand a little bit, you'd have to go and redecorate the tree after that. And of course, you can also just take the pen tool and keep on adding points. So it's actually really fun to be very creative about how you want to decorate your tree, or you could maybe take this file and then add a house and an igloo and start decorating all the things in a scene with just reusing this exact same asset in several different positions. So it's very powerful. You can just duplicate existing light strands and then start decorating other things. And that makes it really, really nice to do things like this. So this is also just the very beginning of what proceduralism can look like in a 2D graphics editor. And we're pretty rapidly now working towards adding more nodes that support this. And one thing that will be kind of a project for the next several months, if not maybe the first half of this year, is going to be redesigning the entire vector format so it is fully procedural. And what that means is we're sort of switching over from an SVG style format for how we are defining our vector data to more of a spreadsheet based format, which is more like a 3D mesh, something you might be used to if you're using Blender geometry nodes. That would be essentially a 3D mesh, except in our case, we just don't use the third dimension, but it allows you to have neighboring shapes that are sharing vertices between faces and things like that. And that would allow us to have much more control over, for example, let's say importing an actual 3D model and using that model as, for example, a grid or some kind of interesting shape. If you just project it and ignore the z-axis, you can basically import a model and use that almost as, as geometry for your scene. But yeah, so that is one example. We also now, as of the past few months, have added this demo artwork page. So basically all you got to do, open up Graphite and then go to go to open demo artwork and basically click on any of these 3 pieces of artwork, and we're going to be adding more as time goes on, and you can continue to play around with some of these. So now it's not just a matter of opening a blank canvas and not really knowing what to do. Yes. So one other feature that we can talk about, we recently added, is the concept of resolution agnostic rendering, or I think we're calling it now, the adaptive resolution system. So what that means is essentially I can keep zooming in and zooming into this, and it's going to recalculate as I zoom in more. It's going to calculate new pixels, and I can just zoom forever. And that is something that, of course, you can't do in any other raster graphics editor, because we're actually rendering those pixels on the fly based upon how you zoom. At the moment, the performance is purely based upon running it on the CPU, so it's actually going to be very slow, but we're going to be pretty soon adopting WGPU, but that is a little difficult to run in the browser because only Chrome and only on Windows and Mac, but not on Linux, currently supports that without using flags. So unfortunately, we're probably going to have to temporarily drop support until the browsers add support for Linux, and basically Linux users will have to enable a flag, as well as people who are not using Chrome, they will have to, or a Chromium-based browser such as Firefox or Safari, they will have to also enable a flag or use the development preview version of their browser. But once the browsers re-enable support for that, we'll be able to speed this up so it's not like 1 frame per second. It will be significantly faster. And that's going to be pretty exciting. So you can actually go zoom in and, like, for example, take the paintbrush tool, which will also be part of the adaptive resolution system soon. We do have a paintbrush tool now, by the way. You can draw things with it, and it's going to be extremely slow because it's also every frame trying to render this fractal. But once we have that part of the adaptive resolution system as well, and that should be in the coming months, I think, you'll be able to then go, for example, hide pieces of text or little drawings or doodles inside a fractal, which would be pretty cool. But hiding the fractal now, we also now have another node, which is pretty cool, which is implementing a noise generator. So this is taking the library called Fast Noise Light, and I ported it all to Rust and upstreamed that as well. And now we have the ability to simply make any type of noise we want. So open Simplex 2 or different variants of it. And then there's a ton of different options. So this is the amount of domain warp to squish it like that. And this is also rendering on the CPU, but it's actually pretty fast because it's only 512 by 512 at the moment. And I'm just going to play around with some of these options because they're kind of fun to play with. And then, of course, you can take multiple of these, combine them together, and create something like a completely procedural material that you might use as a game texture. If you're interested in doing any kind of material designs and you don't have, for example, Substance Designer, you could go ahead and play around with Graphite. It's probably not super purpose-built for the task at the moment, but if you're up for some experimentation, you can, of course, try making some procedural game textures to use in your scenes, which would be pretty cool to see. So please do share them with us if you end up making something like that. But I'll just finish up playing around with a few of these a little bit more. Ooh, that's kind of cool. And then, of course, we can move on from Perlin to a few of these other noise types. And, of course, we've got cellular or Voronoi or Worley noise. It goes by many names. The industry has not really standardized. But you can do some really cool things with them. Yeah. Okay. And then, of course, we do have white noise, which is just simply one random value for each pixel. But yes, so I would now like to talk about our blog post. And basically, I will do a quick summary of it here. And this is talking about everything we did in the past year. And there's a huge amount of really awesome accomplishments that we have completed over the past year. So first of all, of course, we have our drawing, or our little video of us creating a holiday greeting for people using the new procedural system. And if you do open up this blog post, all you got to do is click on this link right here, and that will immediately open up the editor with it already running in your editor. So it's a one-click solution to opening up that demo artwork. So do please give it a try. It's a little fun to drag around that wire and watch the lights reposition themselves. Anyways, I'm going to skip through a few of these, but these are some community meetups that we have. Here is Rafe Levine talking at the Bay Area Rust Gamedev Meetup. Here is one of our contributors who has worked on some of the features in the past, together with me at Embark Studios in Stockholm, Sweden. We visited, and they are the creators of several different libraries in the Rust ecosystem, including Rust GPU, which we use for compiling Rust code to the GPU compute shaders that we run. And then we went and visited Blender in Amsterdam over the summer. So here is Dennis, who is our main node graph engineer. He's the one who's creating our node system, and he's kind of our lead engineer, I guess. And then also the rest of the Blender crew here. We also got the opportunity to do a presentation for the staff at Blender during their lunchtime. So we basically presented on what Graphite is, and that was pretty exciting to talk about the project and give a little teaser to everyone at Blender to show what we're doing for 2D graphics editing. Because, of course, Blender has been very much the inspiration for this entire project. They've shown that it's possible to make a very ambitious 3D graphics editor, and we want to do the same thing for 2D, because for some reason no one has really successfully done it at the same scale that at least suits my expectations of perfection. And then went and visited. Actually, you should probably just read the stuff. I'm going to go a little faster. Also went to SIGGRAPH, which is the main computer graphics conference of the industry. I officially also started an LLC for Graphite, which basically means that we now have a bank account and we can start accepting donations and start working with industry to do contracts and different things like that, and continue to grow the project, which is what's needed. We're still very community focused, but we would like to have the ability to continue growing, and this is that first step. Okay, the website and the user manual and tutorials. We've made some big improvements to the website and also have this tutorial. So please do follow along to this tutorial and create the little sun here that I just showed off. You can create it yourself and learn how to use the editor. And here is basically the development progress report from 2023. You can read this yourself, but the most important things is that we built this node system and finally reached this this minimum viable product MVP version of the procedural graphics editor. And what took a whole year, I can explain here really quickly, is that we started out a year ago in the situation where we had legacy layers, and what legacy layers were was basically just a way of defining artwork or text or images or folders themselves that contain others. They were simply placeholder systems that would store those types of data, and you could draw stuff, and all the tools and all the systems would create shapes and create text and create images and let you import images. And then we also had another system for artboards that you could just simply draw a background. So an artboard is where you simply draw a background and then you can put artwork on top of it. So it's kind of like the page behind the page for the content of what you're drawing. But then we now had to start integrating the node system. So what we did to start integrating the node system is we basically changed it. So instead of having a bunch of separate different type of layers, so a shape layer is different from a text layer, is different from an image layer, and so on, we moved towards having all the layers have their own self-contained node graph. So every layer contained a node graph, and then within the graph, we had the data exported. So we had a shape node exporting from the graph, or a text node exporting from the graph, or an image exporting from the graph, and so on. So we had these graph layers, and we still had also these legacy folders. So these are still legacy layers, but they do contain a graph, and they each individually render to the output of the layer. And we still had our legacy artboard system. But then the next step is that we had to move towards removing the legacy artboard system and replacing the legacy artboard system with this node graph representing your document. So this is kind of the first step of having a single unified node graph across the entire system. So we have all of our artboards, and they end up being part of different layers, and they output to the graph. But we still have these legacy artboards, which means we have two render systems. One is rendering the background for the artboards, and the other is rendering your content getting put on top of it. So that was all very non-standardized, and you couldn't, for example, have one artwork layer interacting with another artwork layer. So in our case, like with the lights here, we need to have the ability to share this common spline across the three different colors of lights, as well as the fourth item, which is the wire itself. So it has to be able to share across different layers. And we end up having this layer, this layer, this layer, and this layer all sharing common data. And you couldn't do that when each of them had their own completely isolated graph. So we're moving towards having a single document graph that started out with just artboards, and then finally we moved towards having to port all the tools and all the editor systems to be able to not work with all these different legacy layers. We had to completely throw away the legacy layer system, and we instead have them working with the nodes themselves. So the tools now interact with the nodes, and they allow you to add layers and drag things around. And then also we had to get rid of the concept of folders that existed before and move those also towards a nesting system within the layers of the node graph itself. So this entire process took a year because there was essentially like 3 different times we had to transition from all the tools using one system to the next version of the system to the next version of the system, because we couldn't just do it all at once because it's such a massive project. We had to be able to kind of do an in-progress, step-by-step approach, showing moving towards the different approaches that we just did and that I just showed with these diagrams. But yes, so with that said, we now have all of these goals. I would encourage you to read them yourself by checking out this blog post. And of course, also, if you are interested in contributing, we now have significantly more resources towards getting new people involved, because a lot of our work this past year was just pretty spread thin, working to get this refactor done, this giant year-long refactor done. But now that it is done, it's unblocked a huge number of tasks that we can all work on in parallel, and we can assign to people who are interested in graphics programming and interested in making procedural systems. And there's a huge number of nodes that we can just, for example, read a research paper or read an algorithm somewhere online and work towards implementing that in a node. So there's hundreds of nodes that we could build, and if you're particularly excited about one item, for example, scattering points across the interior of a mesh or of a shape, and then that way, instead of placing, for example, all these Christmas tree lights at some position along the wire, we can instead have like ornaments placed at random positions along the interior of the tree. So that's just one example of a node we'd like to add. That would be like Poisson disk sampling, but there's really hundreds of these different ones that people could work on. So yeah, and then finally we are now accepting donations. So if you are particularly excited about this project and you would like to see it continue forth, please do consider donating. And we also reached 5,000 stars last month. So if you have not started the project, please do go ahead and give it a star on the GitHub repository. And then while you're at it, take a look at the website and swing by this blog post and give it a read. So yes, thank you. Now, questions.
Oh, I'm not unmuted. Okay, there we go.
Okay, now I hear you.
So yeah, this was super cool to see. I have a few of my own questions, but I have a few from chat first. So first of all, one person asked, will you release a native version of Graphite, or will they be able to build it themselves if they want to use it natively?
Yeah, so that is actually what we're working on at the moment, or we're just getting started with it. It is one of our highest priority items for the next month or two is integrating Tari, and Tari allows us to take the web app essentially and stick it into the web view provided by your operating system, which means it doesn't take very many resources because it's reusing the resources that your operating system is already allocating. And that means that we get to have all of the code running natively. So the rendering code, as soon as we get WGPU running, instead of that using the web GPU sandbox, it will instead use either DirectX or Vulkan or Metal, depending upon your operating system. And then also all the Rust code itself will be running natively as well, which will speed things up because it's no longer having to run client-side with WASM or WebAssembly. It will instead be running everything purely natively directly in the browser. So that's just, directly not in the browser. It will only be doing the front-end display using web technologies. And we do have some far future plans also to even replace that with what hopefully will become successful in the coming years would be Rafe Levine's project Xylem. And that is hopefully going to be the holy grail of GUI and Rust. But of course, time will determine whether that ends up working out. But it is ultimately a research project that is especially beginning in earnest over the coming year, I believe. They just released a blog post indicating that they had some funding from Google to make that project take off in the coming year with several contributors that are working full-time on it now. So that should be exciting, and hopefully a few years from now we may be able to port everything to Xylem.
Super cool. Yeah, so I guess another question here was like, Graphite was built using WASM, so yes, but also what I'm curious about on this front is, since last year, has the usage of WebAssembly changed, or have you unlocked sort of any new features on how you're making use of WebAssembly in the browser?
I don't think we've really changed anything. The biggest was basically just an infrastructure change where we, about just under a year ago, we switched from using our web framework Vue.js to switching to Svelte. And that also meant that our build system changed. And we ended up changing for most of last year to using kind of a temporary one that we weren't very happy with. And we have now just switched that to using Vite, and that has worked very well for us. And that hasn't really changed the way that WebAssembly is used under the hood, but it has simplified our build process. And some of our dependencies that are part of the WASM build chain ended up getting simplified as a result of that. In terms of things that have actually changed in the ecosystem with WASM, one thing is that now Safari has finally added support for SIMD, which means that as soon as we get the chance to, we should be able to enable SIMD. And that means that the older versions of Safari that did not support it would not be able to run Graphite, but that's okay because Safari is already a best effort sort of platform target, because ultimately Safari is always the slowest kid in town for adding web standard features. And that ultimately means we might just have to, on some occasions, direct people to using Chrome or using Firefox.
Awesome, super cool. So a few things from myself. First of all, I love seeing the graph editor. When you're first showing off like the sun moving around, I'm like, oh, you're like doing this stuff in the editor. I wonder what it would look like if it was the graph editor. And then you're like, okay, and now I'll take a look at the graph editor and or the node editor. And
yeah, we want to keep it a surprise. Essentially, we want to let people work with layers just like they're used to in any other graphics editor. And then have the power of switching into the node system, but not being overwhelmed by it if it's not something that they're familiar with or not something that they even need because they're doing simple things. But as soon as they want to have that power, they can jump into it, and now they can start sharing data between layers and make it so that several layers interact with the same data. And then the tools, of course, always update that common data that's shared between layers.
Yeah. And then, I mean, also just on the front of stuff in the editor, like the idea of the infinite zoom is super cool, because I'm like, oh yeah, okay, with vector graphics you can like keep zooming in because it creates it, like whatever you have as a vector, it can do the math to make it go further. But this idea, I suppose, it's like sort of procedurally running code based on how far you're zoomed in. Is that sort of the main concept behind
Yeah,
it?
so because it's procedural, because it's non-destructive, because we're using a node graph to generate your content. In fact, Graphite is essentially, it's almost like a programming tool, except it's visual. So you're using the interface to create artwork, but that artwork is actually Rust code that is a function or a sequence of functions that are built in Rust that run and generate pixels or generate SVG content. And that is the output of your Rust program. And in the future, we'll actually literally be able to compile to a Rust executable, just like use Rustc to build an executable that renders content when you run the program.
Yeah.
And you can also then integrate that into your games if you want it to be something that that takes, for example, the percentage of health that your character has and renders a health bar that you can use as a texture to display in your game. Or you could render like actual textures that get added to the models in your world. For example, if you have a weapon that gets dirtier over time as you start trudging through a swamp, or if you have terrain that ends up getting snowier or wetter or muddier depending upon the seasons, you'll be able to procedurally generate that in Graphite, export it as a program, or export it as like a dynamically linkable thing, binary, and then run that in your game to generate textures on the fly based upon input parameters.
Yeah, I did remember that. I mean, I just remembered that you had talked about this quite a long time ago, and like that was a really cool idea to me. Is like shipping the like the 2D graphic editor with your game so that you can just embed these small types of changes that you'd want to make, or large changes actually. But it seems like it seems so different than any other process I've ever done to like ship something like that along with a game. But it would probably be pretty like efficient and small, I imagine. Because and actually, I was thinking about this when in the blog post here, where you have the Christmas tree and you have like the little button, click on the demo. That demo loads stupidly quickly. Like
Yep, it's already open.
yeah, I know. It's like if I had just read this blog post and I clicked on this, I think I'm looking at a PNG of this entire site. I don't think I'm looking at like actually
But then
a
you can
complete.
scroll.
But then you can scroll, but then you can do literally everything that you can do inside of other tools like this. And so to me, it's just do you have an approximate like knowledge of like what the size of Graphite is right now when it loads?
I think it's about 6 or 7 megabytes if you include the
Yeah, that's so
JavaScript
crazy.
and the Rust WASM binary.
That's so crazy to me. It's
So
like
I do have it cached, but I think it would take less than a second on most internet connections to fully load.
yeah, and then you're just in. You can just start using it.
Yeah.
It's just so different than any other tool of this caliber.
Yeah. Well, of course, we always still want to have our desktop version as our primary target. It's just that it's been so easy to use the web version because as part of our tooling, or as part of our build system and our infrastructure, every single time we ever make a commit to GitHub, it automatically builds a link, a unique link that lasts forever. And we can always open that and try out builds and just simply edit, open them in your browser, look for bugs, compare versions and see how there might have been regressions between versions as we go back in history. And it's just very easy to open. It would be much harder to install an executable every single time we want to run this. So it's just been super duper nice and very, very pleasant to work with. And that's why we've been so far focusing mostly on development and less on the desktop version. But that is changing in the very near future because we do want to start supporting these things that will be not possible in the browser. So one thing we want to add in the coming year is a number of AI models that will allow us to, for example, do segmentation to select different objects in a scene. If you take an image and you want to be able to use kind of like the smart magic wand tool to select a dog or a person or a car or whatever objects that are in the scene, you can very easily select those. And then, of course, we've had our stable diffusion-based Imaginate feature in the past. That is temporarily broken as for this month or two as a piece of culminating that big refactor. We ended up having some small architectural changes that we just haven't been able to quite get to fixing that Imaginate feature. But that allows us to do stable diffusion generations in the editor. And that is something we also would like to work on because that will also potentially be our source of monetization in the coming year as well, is having that Imaginate feature, that stable diffusion integration, and allowing people to generate. And if they want to do more advanced parts of that and they don't want to run it on their own computer, then they can pay us to have an account that that does that. And that can hopefully be a little bit of an income stream that will allow the project to grow.
Awesome. And just one more thing I want to clarify a little bit. So partway through the presentation, you mentioned that you want to integrate WGPU to allow you to use some different features. But I wasn't sure if you conflated that with WebGPU or if there was like two separate things that you have going on here that Graphite's moving towards.
So we sort of use, we have a prototype feature that uses, but we don't actively deploy it at the moment. WGPU, which is the Rust crate that implements the web GPU standard natively. Okay. And one of the platform targets, in addition to Windows, Mac, and Linux with DirectX, Vulkan, and Metal, it also supports the web as a target using the web GPU API that is built into browsers now. Well, built into Chromium-based browsers, except Linux, unfortunately. But hopefully they will add support for that in the very near future because we need it so we can keep deploying Graphite for our users. Once we enable that by default, or more precisely, we enable that as the only way to use Graphite because, it's otherwise prohibitively slow to do things like really advanced raster-based editing once we're trying to work with millions of pixels per second.
Mm-hmm. Yeah. Okay. Super cool. So yeah, I'm definitely excited to see what Graphite has planned for 2024. I mean, with this 2023 blog post, it definitely shows like a lot of really awesome things happening. And so, yeah, Kevin, thank you so much for stopping by this month.
Yeah. Basically, it also just unblocks our team with the morale boost of actually having this big refactor done, and we can actually move towards working on exciting new things instead of working towards just getting this year-long refactor done, which has been a little demoralizing. But now that we're on the other side of it, it's allowing us to be very excited about working on new things.
Yes, absolutely.
So it's going to be this coming year, 2024, is going to be a year with a lot getting done and some major progress. So do be sure to also be sure to subscribe to the newsletter here. We will actually be sending out our first newsletter in the next few days. So if you want to be on the list and get that very first newsletter that we send, then we will attempt to do quarterly if we manage to write content for it every quarter. But it might be difficult to do that because it so far has not happened.
That is always the way of newsletters, I find. All right. Well, thank you very much, Kevin. I hope to catch you next month.
I am looking forward to it.
Perfect. All right, so that's the end of today's meetup. Normally, I would suggest that we hop over to the Rust Gamedev Discord. We can hang out in there. I might pop over there for a few minutes, so I'm going to put the Discord link in chat for anybody who wants to come and chat for a few minutes. But I do have to head back off to the conference that is going on. And so anyways, I hope everybody has a great January. I hope you have some pretty cool stuff that you're working on. As always, if you have something that you want to show off at the Rust Gamedev Meetup, reach out to me. I post a GitHub issue on our Meetup repository where you can sign up for showing off a project. And without further ado, we will see everybody next month.
Bye.